Okay, here we go. Sorry about the delay. Okay, what about this now? If we're factoring something with two terms in it, what's our strategy? What's our strategy for factoring something with two terms in it like this? Yeah, right. We got to find one of the patterns. We got 3 patterns that we've got to match. So let's quickly just see if we can remember what those patterns are. We had a squared minus b squared, difference of squares. And how did that one break down? Chapter 5. A squared minus b squared always factors into good. A plus b, a minus b. Very good. What about a sum of squares? Doesn't work. Good. Tried to get you. Doesn't factor. Okay, what about a difference? We'll do a sum and a difference of cubes at the same time because they're really similar. Remember, they both factor into a small factor and a big factor. What are the terms in the small factor? What goes there and there? A and B. What about in the big factor? A squared, AB, and B squared. Okay, so we just need the signs then. For A cubed plus B cubed, what goes there? Plus. Yeah, the first one is the same as the operation between the cubes. And then, so that's going to be a minus, right? And then what about the next one? Okay, good, it flips. So it's opposite. It flips from positive to negative and negative to positive. And the last one? Always positive. Okay, so those are our patterns. Good. Now, what about this one then? This one, we got to try to fit into difference of cubes, don't we? Looks like there's a little bit of a problem with that, though, because is 4 a perfect cube? No, it's not. Nor is 32. Okay. Any ideas? Ah, okay. Yeah, we always want to see if we can factor out a greatest common factor. So maybe that'll help us. What is the greatest common factor? The biggest thing that divides into both terms? 4. Okay, so I can pull a 4 out front. And if I do that, I'm left with what? No. 4 times what is 32x cubed? Good. 8x cubed minus 1. Okay. So I'm just factoring out a greatest common factor once again, is simply undistributing it, right? Now, this looks a little better. Now we've got to see if we can turn this into something cubed minus something cubed. Still got that 4 out front, but we're done with him. Now we're just trying to work on what's inside the parentheses. So what cubed is 1? Well, 1, right? That one's pretty easy. What about this guy, though? Okay, 2x. Yeah, if I cube the quantity 2x, that means I've got to distribute the 3 to the 2 and the x, and I end up with that result, right? So that works. So then this is like our A, and that's like our B, and all we're going to do is that pattern, right? Okay, see how that works? So then we just end up with, let's do this. We just end up with what? So A cubed is going to be, or excuse me, A cubed minus B cubed gives us this pattern. A minus B is first. So what's that going to look like for us? Good, 2x minus 1. And then we've got A squared. Now that's the one that people are likely to make a mistake on. What's A squared? 4x squared. Ah, good. It's 4x squared. It's the quantity 2x squared. So the 2 is squared and the x is squared. So we end up with the result 4 times x squared. Plus AB So plus 2x, right? And then plus b squared. Well, 1 squared is just 1. So that's it. Okay. No big deal. See, that's the first third of the assignment is that, right? Just finding those patterns. Once you find the pattern, it's very simple. All you do is just plug in, whatever A, B, and C are, plug them in, see what you get. Okay. Remember that when we use the cubes, difference in sum of cubes, the big factor, the quadratic factor, can never go any further. That one's always going to be an irreducible quadratic. If you're solving an equation, if you're solving a polynomial equation and you're setting this equal to 0, right, this whole thing is equal to 0, and you're going to set the individual factors equal to 0, this one right here will never give you any real zeros. It's only going to give you i's. Okay? We don't do a lot with that right now, but later on. All right, so next one. So that's a 2-term problem. Let's look at one with 4 terms. This time I'm going to have you solve an equation instead of telling you to factor. So solve x to the 4th plus 7x cubed minus 56 equals 8x. So get your bearings there. Now, what do we do when we're solving a polynomial equation? Good, we got to set it equal to 0, don't we? Got to put it into standard form. So we're going to subtract 8x from both sides. And then let's go ahead and write the polynomial in standard polynomial form, where the x would go between the 56 and the x cubed. We always want to write it in descending power of x, right? So we'd end up with x to the 4th plus 7x cubed minus 8x minus 56 equals 0. Right? Okay, so what do we do then now when we're solving an equation like this? What's our strategy? Okay, we're going to group them, and the reason we're grouping them is we want to factor it, right? Our goal is if we can break this down. This is too big. This is a 4th degree polynomial. We don't have any magic equation that tells us the zeros of the solutions of a 4th degree polynomial equation. We don't have any magic equation that does that for a cubic either, but we do for a quadratic or linear. Linear equations are easy to solve. Those are a piece of cake. Quadratic equations we can always solve with a quadratic formula, if nothing else, right? So our goal is to try to break this thing apart into a product of smaller factors until we get them small enough, quadratic or less, where we can just set them equal to 0 and solve them, right? So we got to factor it now. 4 terms means we factor by grouping. So we're just going to break it into first group of 2 plus the second group of 2, right? And then you guys, this is getting to be old hat. We've done this quite a bit. What do we do? How do we go about the process of grouping this, factoring by grouping? Okay, greatest common factor of the first group would be what? X cubed. Good. So if I undistribute an x cubed from the first group, what am I left with? Okay, x plus 7. Everybody agree? Okay. Plus, same thing for the second group. Whoops. Okay, good. And we know that, remember that the leftover factor, if it's going to work, those have to be equal. Yeah. Okay. So let's just start with that. We know that if it's going to work, and it may not, those have to be the same. The question is just then, can we undistribute something to make that happen? You know, what times x is negative 8x? Negative 8. So does that work for the other one? Negative 8 times 7, negative 56? Yeah, it does. Okay. So then we've got, each group has a red and a blue factor in this case, right? The blue ones are the same, so we can pull that out, divide that away from each group, right? Leaving us with what? If I divide out the x plus 7s out front, x cubed minus 8 plus negative 8. Okay, good. Now we've gotten them broken down. This first one is done. What's the solution of that factor? If I set it equal to 0. -7. So -7 is one of our solutions. Maybe there are more. What about this one? We can simplify this further. Now, how do we go about this one? If I've got an x cubed minus 8, that we don't have a magic cubic formula. We have a quadratic formula, but no cubic formula. Could we break that further? That's a difference of cubes, isn't it? Yeah, we could write that as, we could write this one as x cubed minus 2 cubed, which would break up into what? Good, x minus 2. So there's that. Our a is x and our b is 2. So we get a minus b times a squared. Good. Plus. Good. 2 squared, so 4. Okay. And then out front we've still got our x plus 7. And the whole thing equals 0. So now all we have to do, now we're done, almost. I mean, all we have to do is find out what the numbers are. We've gotten this thing broken apart far enough, right? This is linear, x is to the first power, linear, x to the first power, quadratic, x to the second power. So finding the solutions of those is easy. We can do it either just by, linear ones are simple, quadratic ones. If we needed to, we could use the quadratic formula. Now, what are our zeros going to be? You already told me that one is -7. What's this one? Now, what about the zeros of that one? Anybody tell me about that? We could do it. We could use the quadratic formula. But remember what I told you about if you use the cubic factoring patterns, the quadratic factors, are they ever going to have real zeros? Never. So you could do it. You'd be wasting your time. That's going to give us only i's back for our answer. Okay? And if we're looking for real zeros, which usually we are, we don't care about the i's. Now, if we wanted to find the i's, for whatever reason, if we wanted to find all the complex solutions, then the quadratic formula would give those to us. Just set that equal to 0, and it would give us back 2 answers with i's. But we're looking for real solutions. So this one, no reals. So those are our 2 zeros. Okay? Make sense? All right. Let's look at one more of these. Okay, what if we wanted to solve one like this? Okay, first step would be what? Set it equal to 0. Good. Now, what do you think small question, do we want to subtract 4x to the 4th from both sides, or do we want to move the other 2 terms over? I can see why people would say the 4x to the 4th. It's only moving one thing. But remember, think ahead just a little bit here. When we do, we're going to get 3 terms in this thing, aren't we? Right? What's our strategy for either factoring or just generally solving a 3-term polynomial equation? Okay, good. We're gonna try to group this thing or look at it in a way where it looks like a quadratic pattern, right? And with the quadratic patterns, remember back to chapter 5, we always wanted to have a being positive, didn't we? Right. So and that's generally a good idea. If you can leave the leading coefficient being positive, that's always helpful. So let's move these 2 over instead. So that's going to give us, what, 4x to the 4th minus 5x squared minus 9 equals 0. All right, so that's a 4th degree polynomial. So we're going to have to somehow do a trick on this, either break it down and factor it into smaller pieces or maybe even something else because it's quadratic. We could factor this. But it's not the kind that are easy to factor because it's got a 4 in front of the first term, right? A is 4. And so when we factor those, remember, that's the A times C then split B stuff. And that's kind of tedious. What might we do instead? We're trying to solve this. Well, okay, so let's regroup it first. Good idea. Let's let's think of this. Let's break this x to the fourth up and make it an x squared squared. So I've got 4x squared squared minus 5x squared minus 9 equals 0. Now, if we had done this problem in chapter 5, it might have looked like this. Just 4x squared minus 5x minus 9 equals 0. And how would you have solved that in chapter 5? Would you want to do a factored that? Heck no. What would we do instead if we're solving a quadratic equation in standard form? Quadratic formula, right? What's A, B, and C? A is 4, B is -5, C is 9. -9, right?
Yeah.
So we could use our quadratic formula, right? X equals -b plus or minus square root b squared minus 4. There you go. You don't want me saying it. So if we plug that stuff in, we get an answer, right? We get x equals -b would be +5 plus or minus the square root of b squared. We always square the positive instead of the negative. So we get 25 minus 4 times 4 times -9, right? So that's going to make the whole thing positive. And all over 2a, so 8. And we can simplify that. We get 2 answers out of it, one for the plus and one for the minus, right? So what are we going to do over here? What's the difference between the left and the right in this case? Yeah, the only difference is here, the quadratic formula was written in terms of x's, or like our quadratic equation. Here it's in terms of x squares. That's it. So the formula part is going to be exactly the same. The formula part is going to look like -b plus or minus square root b squared minus 4 times a times c divided by 2a. But what goes out front this time, oh, jeez, that's bad action. Oh, what's it doing? I don't think that's me. Well, maybe it was. I guess it was. Is x squared, right? And so we're going to get an answer for x squared from the plus part and one from the minus part, and then we'll have to maybe just see what those solutions are in each case, right? So if we try both of those, if we take the plus, we get x squared equals, let's see, 5 plus square root 25. 36 times 4 would be 144, 25, 169. Square root of 169, which would be 13, right? Okay, so that's 18 over 8, which reduces to what? 9 over 4. Okay, so there's one answer for x squared. If we take the minus, we get x squared equals, well, we're going to get the same stuff up here, aren't we? It's just going to be a minus sign. So we're going to get 5 minus 13. So -8 over 8 equals -1. Question?
Well, okay, so we're trying to find the x squared, right?
Mm-hmm.
Well, do you have to make it to x equals just x squared?
Oh, no, we have to get x. You're right. We're not done.
Then you just square root both of
Yep.
them, and then
Yep.
essentially you can 3 over 2, and then that would be
Exactly.
square root
Right.
1.
Right, so if we have x squared equals 9/4, if I square root both sides, then isn't x equal to plus or minus the square root of 9/4, which is just the square root of 9 over the square root of 4, right? So I get 2 solutions there. X equals plus or minus 3/2, and then I've got to take care of the bottom. Well, on the bottom one, if I have x squared equals -1, what's going to happen when I square root both sides? I'm going to get i's out of those. So these are non-real. So we can just forget about those. Right? But I did get two real solutions, plus and minus 3/2. Okay? Make sense? Now, we happen to get one. I don't remember if I had showed you when we were using quadratic formula. So it didn't have to be one like that. If this had been something that was easy to factor, we would have just factored it, right? And I would have had, in my factors, I would have had x squareds, and then I could have just set those factors equal to 0 to solve them. Does that make sense? Okay, good. All right, that's 6-4. That's all there is to it.